Hello, and welcome to the Deep Space Relax channel. It's truly lovely to have you here with us tonight. Forests are some of the most remarkable places on our planet. They are far more than simple collections of trees. They are living systems that breathe, expand, and shape the very air that keeps us alive. Some forests are so enormous that they generate their own weather patterns. Some trees have existed since long before the pyramids were ever built, and beneath the soil, hidden fungal networks allow trees to quietly communicate with one another across the darkness. In the Amazon, more species live side by side than anywhere else on Earth. In the frozen taiga, forests stretch across entire continents, storing more carbon than all of the world's oil reserves combined. And in the misty heights of cloud forests, water drips straight from the sky onto the leaves. Forests are ancient, powerful, and endlessly full of wonder. And tonight, we will wander together through 100 fascinating truths about them. If you enjoy these gentle journeys, you may consider liking and subscribing or sharing your thoughts in the comments below. It helps others find their way here as well, one sleepy soul at a time. But for now, there is nothing you need to do. Let your shoulders relax. Let your breathing settle into its natural rhythm. Imagine the quiet hush of a forest at dusk, when the light fades and the canopy slowly closes overhead. And now, if you are ready, let us begin. The largest living organism on Earth is a forest fungus. Hidden beneath the soil of Oregon's Blue Mountains lies something that feels almost impossible to imagine. At first glance, the surface appears ordinary, scattered with trees, fallen leaves, and forest debris. But underneath it all stretches the living threads of a single fungus, weaving through the earth like a vast underground web. This organism, Armillaria ostoi, covers nearly 4 square miles and is believed to be thousands of years old. While its mushrooms appear briefly above the ground, the true body of the fungus exists below, formed from an immense lattice of microscopic filaments known as mycelium. Scientists recognize it as the largest living organism on the planet, far larger than any whale, tree, or coral reef. What makes this organism so extraordinary is not only its size, but its quiet endurance. Year after year, it slowly spreads beneath the forest, connecting trees, feeding on roots, and reminding us that life can be hidden from view and still unimaginably vast. The Amazon rainforest alone contains 10% of all known species on Earth. Often described as the crown jewel of global ecosystems, the Amazon earns this title for good reason. Across its massive green expanse that stretches through 9 countries, lives an astonishing portion of Earth's biodiversity. 1 out of every 10 species known to science calls the Amazon home. This includes millions of plants, animals, insects, and fungi sharing space beneath the towering canopy. Jaguars move silently along the forest floor, while pink river dolphins swim through winding waterways. Entire colonies of ants cultivate underground fungus gardens, while orchids cling high above on branches. Scientists believe that thousands, perhaps even millions, of species remain undiscovered within its depths. The Amazon is not only diverse, it is densely packed with life layered from dark soil to sunlit treetops. To walk through it is to step inside a living encyclopedia of the planet, unfolding leaf by leaf and sound by sound. The boreal forest stores nearly twice as much carbon as all the world's oil reserves combined. Stretching like a vast green crown across Canada, Russia, and Scandinavia, The boreal forest may not be as famous as the Amazon, yet its influence on the planet is enormous. Beneath endless expanses of spruce, pine, and larch lies one of Earth's greatest carbon storehouses. Much of this carbon is locked deep within soils and wetlands, preserved inside cold, slow-decaying layers of moss and peat. Scientists estimate that the boreal forest contains almost double the amount of carbon found in all known global oil reserves. This makes the boreal forest a powerful buffer against climate change, quietly capturing and holding carbon for centuries. However, rising temperatures are beginning to thaw permafrost, increasing the risk that this stored carbon could be released back into the atmosphere. In many ways, the boreal forest functions like a giant vault, and the future stability of Earth's climate depends on keeping that vault securely closed. The Amazon rainforest creates its own rain. When people imagine rainforests, they often picture storms arriving from distant oceans. But the Amazon works differently. It does not simply receive rainfall, it actively produces it. Each day, countless trees draw water from the soil and release it into the air through tiny openings in their leaves. This invisible vapor rises upward, forming thick clouds that eventually break apart into rain. Scientists call this process evapotranspiration. In the Amazon, it creates an atmospheric river that cycles moisture repeatedly over the forest. A single large tree can release hundreds of gallons of water into the air in just one day. Without this cycle, the forest would slowly dry out. With it, the Amazon sustains its own weather system, generating storms, feeding rivers, and sending moisture across vast distances, even reaching regions such as the American Midwest. It is a self-sustaining engine of life, a forest that drinks and rains in the same continuous breath. Some trees communicate through underground fungal networks. Beneath nearly every forest lies a hidden communication system made of fungal threads linking tree roots together into a massive interconnected web. Scientists often call it the wood wide web because it allows trees to exchange signals and resources. Through these networks, shaded seedlings can receive nutrients from larger, healthier neighbors. Trees under attack by insects may send chemical warning signals, prompting nearby trees to strengthen their defenses. Some species even behave like parent trees, transferring energy to younger saplings through these underground pathways. While this is not communication in the human sense, it represents cooperation carried out molecule by molecule beneath the soil. What appears to be a silent forest is actually full of constant exchange, not through sound or sight, but through sugars, chemicals, and fungal connections. The forest, it turns out, is far more connected and alive than it appears on the surface. The oldest known trees began growing before the pyramids were built. High in the mountains of California and Nevada, far above desert landscapes, grow trees so ancient that their lifespans stretch back into prehistory. These bristle-cone pines, twisted and shaped by centuries of wind and snow, are the oldest individual living organisms on Earth. Some are nearly 5,000 years old. That means they were already ancient when the first pyramids rose in Egypt. They have endured the rise and fall of civilizations, surviving droughts, wildfires, and freezing winters. Their secret is not speed, but patience. They grow extremely slowly, so slowly that even after thousands of years, many remain no taller than an average suburban house. Their wood is dense, rich in resin, and highly resistant to decay. To look at a bristlecone pine, is to witness a living being that has endured through nearly all recorded human history. It is a reminder that time moves very differently for trees. The Amazon rainforest may be approaching a dangerous tipping point. Despite its enormous size, the Amazon is surprisingly fragile. Scientists warn that it may be nearing a threshold beyond which it could begin to collapse. As deforestation expands and climate change dries the air, parts of the rainforest may shift into a savanna-like ecosystem. This would mean fewer trees, reduced rainfall, and irreversible disruption of the forest's natural cycles. Some regions of the Amazon already release more carbon than they absorb, reversing its ancient role as a carbon sink. If the forest crosses this tipping point, billions of tons of stored carbon could be released into the atmosphere, accelerating global warming. At the same time, countless species would lose their habitats. The collapse of the Amazon would reshape not only South America, but the entire planet's climate system. It serves as a reminder that even the strongest ecosystems depend on delicate balances that can be pushed too far. The Congo rainforest stores more carbon than the entire United States emits in a decade. Second in size only to the Amazon, the Congo rainforest is often overlooked, yet its role in stabilizing Earth's climate is immense. Beneath its dense green canopy lies one of the largest carbon reservoirs on the planet. The forest itself, together with its vast peatlands, holds more than 80 billion tons of carbon. To understand this scale, consider that it exceeds the total carbon emissions produced by the United States over 10 years of burning fossil fuels. Much of this carbon is trapped in waterlogged peat soils, where oxygen cannot easily break organic material down. Rising temperatures and human disturbance now threaten to unlock this storage. Scientists warn that if these peatlands dry out, the release of carbon could be catastrophic. For now, the Congo rainforest stands as one of Earth's most powerful natural protectors, a green fortress quietly holding back the advance of climate change. The tallest trees on Earth grow higher than a football field is long. Standing at the base of a coastal redwood in California and looking upward can feel endless. These giants, some exceeding 370 feet in height, are the tallest living organisms on the planet. To imagine their scale, picture a football field placed upright. The redwood still rises beyond that height. Their upper branches sway in winds that cannot be felt at ground level, and entire ecosystems thrive high above, including mosses, ferns, and even small salamanders. Redwoods grow in fog-covered groves along the Pacific coast, absorbing moisture directly from the air. Despite their immense size, they survive only within a narrow climatic range, making them surprisingly vulnerable. Yet they stand as powerful symbols of nature's ability to reach skyward, stretching toward the clouds with quiet endurance unmatched anywhere else on Earth. Redwoods can live for more than 2,000 years. These towering giants are not only the tallest trees on Earth, but also among the longest living. Some redwoods have stood for over 2 millennia, silently witnessing centuries of human history unfold. Their thick, fibrous bark protects them from insects and fire, allowing them to endure where other trees would fall. When fires pass through their forests, the flames often clear away competing vegetation while leaving the redwoods largely unharmed. Their roots, although relatively shallow, interlock with neighboring trees, binding entire groves together into networks of shared support. In this way, a redwood forest becomes more than a collection of individual trees. it becomes an ancient living community. Walking among them feels like stepping into a natural cathedral where towering pillars rise into mist and time seems to stretch beyond comprehension. They remind us that endurance itself can be a form of strength etched into wood and centuries. Cloud forests collect water directly from the sky. High in mountain regions, where mist constantly drifts through treetops, exist forests unlike any others on Earth. Cloud forests remain wrapped in fog for much of the year, and the trees within them have evolved to capture moisture straight from the air. Leaves and moss-covered branches comb water from passing clouds, transforming mist into droplets that drip steadily to the forest floor. In this way, these forests drink directly from the sky, even when rain does not fall. This adaptation allows cloud forests to survive in areas where rainfall alone would not be sufficient. The water they capture often feeds streams and rivers that flow into valleys below, supporting ecosystems and human communities alike. To walk through a cloud forest feels like stepping inside a living cloud, where every surface glistens and drips, and the air itself becomes part of the forest's hidden pulse. Some forests glow at night with bioluminescent life. Enter certain forests after dark, and you may witness a soft, otherworldly glow. Tiny mushrooms scattered across fallen logs emit faint green light, appearing like lanterns in the darkness. This phenomenon, known as bioluminescence, is produced by chemical reactions inside the fungi. Scientists believe the glow may attract insects that help spread fungal spores, aiding reproduction. In tropical forests, entire patches of undergrowth can shimmer faintly, creating scenes that resemble starlight scattered across the forest floor. Fireflies add to this effect, flashing between branches like sparks. For centuries, people described these glowing forests as enchanted places. Today, researchers continue to study the chemistry behind the light, seeking to understand why some species evolved this ability. To the human eye, it feels like magic, a quiet electricity flickering to life in the dark, reminding us that forests can shine even when the sun has set. Some forests depend on regular fires as part of their natural cycle. Although fire may seem destructive, it is a natural and essential process in many forest ecosystems. In regions such as North America's pine forests and Australia's eucalyptus woodlands, fires pass through landscapes every few years. These burns clear thick undergrowth, return nutrients to the soil, and even trigger certain trees to release seeds. Without fire, these ecosystems would weaken rather than thrive. Pine trees, for example, produce cones sealed with resin that only open when exposed to intense heat. After a fire, nutrient-rich ash creates ideal conditions for new growth. Animals have also adapted to this cycle. Some birds follow smoke to hunt insects fleeing the flames. When humans interrupt these natural fire rhythms through suppression or logging, fires can grow dangerously intense. But when allowed to occur naturally, forest fires serve as renewal events, resetting ecosystems and allowing new life to emerge. Fire can awaken seeds and trigger new forest growth. After a wildfire passes, the ground may appear blackened and lifeless, yet beneath the ash lies a hidden promise of renewal. Some seeds wait for years, even decades, for the heat of fire to unlock their protective shells. Certain plants, such as lodgepole pines and Australia's banksia, have seed coatings that only open under extreme temperatures. Other species respond to chemicals released in smoke, which signal that conditions are finally right for growth. As a result, just weeks after a fire, Forest floors can erupt in green, covered with seedlings that could not have sprouted without flames. Fire becomes not only a force of destruction, but also a powerful catalyst for regeneration. It clears space, allows sunlight to reach the soil, and awakens a new generation of plant life. In this way, the forest's cycle of life and death is quite literally written in fire. Some trees can survive lightning strikes. When lightning tears through a forest, the sound and flash can be terrifying. Trees often take the full impact, and many split or burn. Yet some manage to survive these powerful strikes. Their survival depends on bark thickness, moisture levels, and internal structure. Trees with thick, insulating bark can direct electricity along outer layers, protecting living tissue inside. Moisture within the trunk can also help conduct the current quickly, reducing internal damage. Over time, some trees even heal around lightning scars. Darkened grooves spiral upward along their bark, becoming permanent marks left behind by storms. These scars serve as silent records of past battles with the sky. Trees that endure lightning strikes stand as symbols of resilience, continuing to grow despite nature's most powerful forces attempting to bring them down. In the frozen taiga, trees can split apart in extreme cold. The taiga, Earth's largest forest biome, stretches across Siberia, Canada, and Scandinavia. Winters here are brutal, with temperatures sometimes falling below -60 degrees Fahrenheit. In such severe cold, trees can suffer damage that seems almost unreal. Sap inside trunks can freeze so rapidly that it expands faster than the wood can tolerate. This sudden pressure can cause trunks to rupture with loud cracking sounds that resemble gunshots. In rare cases, parts of trees may even burst outward, giving rise to stories of exploding trees. Although many species have evolved antifreeze-like chemicals to protect their tissues, these defenses are not always enough. The splitting trees of the taiga reveal just how harsh this environment can be, where survival pushes every living organism to its absolute limits. Some forest fires burn underground for years. Not all fires disappear once surface flames are extinguished. In certain forests, especially those with peat-rich soils, fires can continue smoldering beneath the ground long after landscapes appear calm. These so-called zombie fires can persist for months or even years, slowly creeping through layers of carbon-rich peat. They may resurface long after wildfire seasons have ended. Some scientists believe these fires can even survive winter beneath snow, re-emerging in spring. These hidden blazes release massive amounts of carbon into the atmosphere and are extremely difficult to extinguish because water rarely penetrates deeply enough to reach them. The scent of smoke can linger across large areas even when no flames are visible. These fires serve as reminders that forests can hold on to both life and destruction far longer than we might expect. Forests can help generate their own lightning. Forests do not only endure lightning strikes. In many cases, they help create the conditions that produce them. As water vapor rises from leaves into the atmosphere, it feeds storm clouds above the canopy. Inside these clouds, ice particles and droplets collide, building strong electrical charges. Dense and humid forests, especially rainforests like the Amazon, release enormous amounts of moisture into the air each day, making them powerful storm generators. The result is frequent lightning activity, sometimes with thousands of strikes occurring across large forest regions in a single night. Some studies even suggest The tiny particles released by trees influence how storm clouds form and behave. In this way, forests are not passive recipients of lightning, but active contributors to the atmospheric processes that create it. Each flash of light in the sky can be traced back, in part, to the steady breathing of countless leaves. Some forests survived even during the ice ages. During Earth's great ice ages, massive glaciers covered much of the northern hemisphere. It might seem that forests would have vanished completely, yet certain regions provided shelter from the worst cold, allowing isolated pockets of trees to survive. These refuge forests became green sanctuaries surrounded by frozen landscapes. When glaciers eventually retreated, these surviving forests expanded outward again, recolonizing vast territories. Modern genetic studies of trees reveal traces of these ancient refuges, showing lineages that stretch back tens of thousands of years. The survival of these forests is one reason so many tree species still exist today. Without them, much of Earth's forest life might have disappeared forever. They stand as proof that even during the harshest periods of planetary history, life found ways to endure and persist. Beneath the ice of Antarctica lie fossilized forests. Today, Antarctica is a land of ice and endless snow, but long ago it was covered with trees. More than 200 million years ago, before the continent drifted into its frozen isolation, it lay closer to the equator and supported vast forests. Fossil discoveries reveal preserved stumps, roots, and even entire petrified trunks buried beneath layers of rock and ice. Some evidence suggests that dense polar forests once thrived there, enduring months of darkness in winter and constant sunlight during summer. Modern scientists drill into Antarctic rock and uncover remnants of this lost world, including leaf impressions, fossil wood, and traces of ancient soil. These discoveries show how dramatically Earth's climate and continents have shifted across deep time. To imagine forests growing where glaciers now dominate is to glimpse a planet constantly reshaping itself over millions of years. The Amazon River once flowed in the opposite direction. Today, the Amazon carries more water than any other river on Earth and flows eastward into the Atlantic Ocean. But millions of years ago, it traveled westward toward what is now the Pacific. Geological forces reshaped South America as the Andes Mountains rose and blocked the river's original path. Over time, the Amazon reversed its direction, creating new floodplains, shifting ecosystems, and permanently transforming the surrounding forest. This reversal changed how sediments and nutrients moved across the region, enriching soils that would later support extraordinary biodiversity. It also created habitats where countless species evolved. Without this monumental shift, the Amazon rainforest as we know it today might never have existed. Even the largest rivers on Earth are not fixed in place. They respond to deeper movements of the planet, shaping entire living worlds in the process. In some rainforests, rain rarely reaches the ground. In certain tropical forests, the canopy is so thick that much of the rainfall never touches the soil below. Instead, layers of leaves and branches capture water high above the forest floor, creating suspended reservoirs of moisture. Plants known as epiphytes grow on tree trunks and branches rather than in soil, drawing water directly from intercepted rain and mist. For many animals, this upper layer becomes a complete habitat of its own, with tiny streams, pools, and micro-ecosystems that never descend to the ground. Scientists who climb into these canopy zones often describe them as entering a separate world hovering above the forest. Meanwhile, the soil below may remain dry for days, even while heavy storms rage overhead. These forests demonstrate that rain does not always fall straight down. Sometimes it is caught, stored, and shared long before reaching the earth. Rainforests can create powerful thunderstorms. Thunder rolling across rainforest skies often does not come from distant weather systems. In places like the Amazon, the forest itself drives storm formation. Through evapotranspiration, trees release enormous amounts of water vapor into the atmosphere. This rising moisture forms thick clouds that grow heavy and unstable. By afternoon, these clouds frequently erupt into thunderstorms, filled with lightning and thunder. The rainfall feeds the forest, which then releases even more moisture, continuing the cycle. The scale of this process is immense. The Amazon alone pumps billions of tons of water into the atmosphere every year, sustaining its own weather patterns. In this way, rainforests do not simply respond to climate. They actively create it, shaping storms from the breath of leaves and the heat of the sun. Forests can generate their own winds. Wind is often associated with oceans and global atmospheric circulation, yet forests also play a role in shaping air movement. As sunlight warms the forest canopy, heated air rises upward, pulling cooler air inward from surrounding areas. This creates gentle but persistent breezes that circulate within and around forest ecosystems. In massive rainforests, such as the Amazon, these localized air movements can grow strong enough to influence regional weather patterns. Leaves contribute as well. Their textured surfaces slow passing air and create turbulence that mixes and stirs the atmosphere. Forests do not simply exist beneath the sky. They actively sculpt the movement of air itself. Standing in a forest clearing, you may feel a soft breeze that was not born from the ocean or distant mountains, but from the living machinery of leaves and trunks around you. Tropical forests release invisible rivers of water vapor. Forests do not only exchange oxygen and carbon dioxide with the atmosphere, they also release enormous amounts of water. A single large tropical tree can emit hundreds of gallons of water vapor into the air each day. Multiply this by billions of trees, and the result is massive atmospheric rivers flowing invisibly above the canopy. In the Amazon, these vapor streams can stretch thousands of miles, transporting moisture far beyond the forest itself. They help drive rainfall across South America and influence weather in distant regions. This process supports agriculture, ecosystems, and climate stability well outside forest boundaries. Scientists often describe the Amazon as a giant natural humidifier, lifting water from the ground and sending it into the sky. Through this constant exchange, forests blur the boundary between Earth and atmosphere, shaping weather on a planetary scale. Certain forests release aerosols that help form distant clouds. When forests send water vapor into the air, they also release countless microscopic particles known as aerosols. These particles originate from plant compounds, soil organisms, and tiny microorganisms carried by rising air currents. High in the atmosphere, aerosols serve as tiny seeds around which water droplets gather, forming clouds. Some of these clouds drift thousands of miles before releasing rain. In this way, the breath of a forest can help bring water to faraway lands. Scientists have traced aerosols from the Amazon influencing rainfall patterns, even across the Atlantic Ocean. Although researchers are still uncovering the full chemistry, Behind this process, the conclusion is clear. Forests extend their influence far beyond their borders. They do not only create rain for themselves, they actively participate in shaping the global water cycle, linking distant regions through invisible pathways in the sky. The fresh scent of pine trees is connected to climate processes. That crisp, clean smell you notice while walking through a pine forest is more than just pleasant. It comes from organic compounds called terpenes that trees release into the air. These chemicals give forests their distinctive aroma, but they also play a role in atmospheric chemistry. Once released, terpenes can react with sunlight and other compounds to form tiny airborne particles that influence cloud formation. By altering how sunlight interacts with the atmosphere, these reactions can slightly cool the surrounding climate. In this way, the familiar scent of pine is tied to processes that ripple upward into the sky. Breathing in forest air becomes part of a cycle that connects soil, leaves, and atmosphere. Even something as simple as a smell can quietly shape the balance of Earth's climate. Forests cool entire regions by several degrees. Step into a forest on a hot summer day, and the temperature drop is immediate. Shade plays a role, but deeper processes are also at work. Through transpiration, trees release water vapor that absorbs heat as it evaporates, creating a natural cooling effect. This biological air conditioning can lower local temperatures by several degrees. On a larger scale, vast forests such as the Amazon cool entire regions, influencing weather systems and stabilizing climate patterns. Cities surrounded by forests often remain cooler than areas bordered by open land. In a warming world, this cooling function becomes essential rather than optional. Forests act as natural thermostats, quietly regulating heat through constant invisible processes. Every leaf contributes to this balance, helping ease the planet's rising temperature. Forests help keep polar regions frozen. It may seem surprising, but tropical and boreal forests influence the stability of Earth's ice-covered regions. Moisture and heat released from forests affect atmospheric circulation patterns that extend across hemispheres. These global air movements help regulate temperatures in polar areas. Forests also store vast amounts of carbon, preventing greenhouse gases from accumulating in the atmosphere and accelerating ice melt. Boreal forests near the Arctic further protect permafrost by shading snow and insulating frozen ground. The fate of polar ice is deeply connected to the fate of forests. What happens in Earth's green belts ripples outward to its frozen edges. Protecting forests helps preserve glaciers, sea ice, and coastal stability around the world. Forests influence global wind patterns. Forests do not simply exist beneath the atmosphere. They actively shape how air moves across the planet. By releasing large amounts of water vapor, forests create pressure differences that help drive winds over long distances. This effect, often called the biotic pump, pulls moist air inland from oceans and supports rainfall across continents. Without it, many interior regions could dry out and turn into deserts. Research suggests that forests influence not only local breezes, but also major atmospheric circulation systems, including jet streams and storm paths. Leaves swaying in one region can influence weather thousands of miles away. Winds that bring rain to farmland or steer storms across oceans may owe part of their direction to the silent work of trees. Some trees release chemicals that affect human emotions. If you have ever felt calmer while walking through a forest, science may help explain why. Many trees release airborne compounds known as phytoncides, natural chemicals that protect plants from insects and disease. When humans inhale these substances, studies suggest they can reduce stress hormones, lower blood pressure, and even strengthen immune responses. This is one reason why forest bathing, a practice that originated in Japan, has gained popularity as a therapeutic activity. Breathing in the scents of cedar, pine, and cypress does more than soothe the senses. It produces measurable changes within the body. Forest air is not only rich in oxygen, it carries subtle natural medicine, revealing how deeply human biology remains connected to the environments in which it evolved. Forest sounds can lower stress hormones. Close your eyes in a forest, and sound becomes the dominant sense. Leaves rustle in the wind, birds call across branches, insects hum, and water drips from moss-covered limbs. Research shows that these natural soundscapes can significantly reduce cortisol, the hormone associated with stress. Unlike the chaotic noise of traffic or machinery, forest sounds follow gentle patterns that the brain interprets as safe. This calming effect slows heart rate, deepens breathing, and relaxes the nervous system. Some hospitals even use forest recordings to support patient recovery. Urban planners study how natural soundscapes might improve mental health in cities. Still, nothing compares to the immersive chorus of a living forest. Listening to it feels like resetting the mind, reminding us that healing can be found in the quiet voices of nature. Forests can change the color of the atmosphere. On warm, hazy days, you may notice a faint blue tint stretching across forested horizons. This effect is not an illusion. It's created by the chemistry of trees. Forests, especially those dominated by pine species, release organic compounds that scatter sunlight in specific ways. This scattering alters how light travels through the air, giving the atmosphere a soft bluish hue. In places such as the Appalachian Mountains, this phenomenon is so visible that the region earned the nickname the Blue Ridge. What you see is not only distance or mist, but the invisible breath of trees shaping how light behaves. Forests literally color the air around them, changing the way landscapes appear to human eyes. Every shimmering ridge and glowing horizon is influenced by countless leaves releasing microscopic particles into the sky. The night sky above forests can glow with invisible radiation. When you step into a forest at night, darkness may seem complete. Yet above the canopy, the atmosphere often glows faintly with energy invisible to human vision. This phenomenon, called air glow, is produced by chemical reactions high in Earth's upper atmosphere. Forest regions usually have lower light pollution, making this subtle glow easier to detect with sensitive instruments. Some nocturnal animals and insects may even be able to perceive these faint emissions, using them for navigation or orientation. In this sense, the night sky above forests is never truly dark. It carries a quiet radiance beyond our perception. For humans, this adds another layer of mystery to nighttime forests, reminding us that even in darkness, light continues to flow above the treetops. Forest air contains countless microscopic particles from trees. Every breath taken in a forest carries far more than oxygen alone. The air is filled with microscopic particles released by leaves and soil, including water droplets, organic compounds, spores, and pollen. These particles act as invisible messengers of the forest, drifting upward to help form clouds, or settling back into the soil. Some even become seeds for raindrops, influencing when and where rain falls. For humans, forest air often feels fresher and cleaner than city air, partly because these natural aerosols help filter pollutants. Breathing forest air means joining a living cycle of chemistry and biology that extends far beyond the visible trees. A single teaspoon of forest soil holds billions of organisms. Beneath fallen leaves and soft moss lies an unseen universe. A single teaspoon of forest soil can contain billions of microscopic organisms. Bacteria, fungi, protozoa, and tiny nematodes thrive in this dark, damp world, breaking down organic matter and recycling nutrients. Many of these organisms remain unknown to science, yet together they form the foundation of forest health. They nourish tree roots, shape soil structure, and protect plants from disease. Without this underground life, towering canopies would collapse. In many ways, a forest's greatest biodiversity exists not above ground, but beneath our feet, hidden in a microscopic galaxy of life. Forest floors breathe carbon in daily rhythms. Forests do not only exchange gases over seasons, they breathe on daily cycles as well. At night, when photosynthesis stops, soil and roots release carbon dioxide, causing levels to rise close to the forest floor. During daylight, trees absorb this carbon again, lowering its concentration. These daily pulses are so regular that scientists can estimate time of day by measuring carbon levels alone. The entire ecosystem follows a rhythmic pattern tied to the movement of the sun. This quiet breathing reminds us that forests are not static landscapes. They are dynamic systems constantly inhaling and exhaling with the turning of earth. Insects can outnumber leaves in some forests. Leaves may seem endless in dense forests, yet in certain tropical ecosystems, insects exist in even greater numbers. Ant colonies can number in the millions. Termites build towering mounds. Beetles crawl across bark and soil in unimaginable variety. Scientists estimate that a single hectare of rainforest may contain more than 40,000 insect species, with countless individuals filling every layer of the ecosystem. Many of these insects have never been formally studied. Their abundance is not background noise. Insects pollinate plants, recycle nutrients, and serve as food for countless animals. Without them, forests would unravel. Their sheer numbers make them the true engine of life beneath the canopy. Some forest plants trap and consume insects. Forests are not only full of insects, they also host plants that feed on them. Carnivorous species such as pitcher plants and sundews attract insects with sweet scents or sticky surfaces. Once captured, enzymes break down their prey, providing nutrients that poor forest soils often lack. In tropical regions, some pitcher plants grow large enough to trap frogs or small mammals. These unusual feeding strategies reveal how competition drives innovation in nature. In shaded understories, where sunlight is limited and soil nutrients are scarce, plants evolve surprising solutions. Watching a plant consume an insect offers a glimpse into evolution's creativity and adaptability. Forests harbor countless viruses that remain undiscovered. Deep within forest soils, freshwater pools, and even inside the bodies of animals and insects, enormous numbers of viruses exist beyond what we can easily imagine. Many of these remain completely unknown to science. Some play roles in regulating microbial populations, helping maintain balance within ecosystems. Others may one day prove valuable to medicine or biotechnology by carrying genetic tools that inspire new treatments. Forests act as vast libraries of genetic diversity, and viruses are part of this hidden archive. While some can cause disease, many exist quietly, interacting with hosts without harm. Studying them is challenging because they often remain dormant or difficult to detect. Still, one truth is clear. Forests are not only home to towering trees and visible wildlife, but also to invisible biological worlds that may shape the future of science. The rainforest canopy can be as dense as solid structures. Standing beneath a tropical rainforest canopy, it becomes clear how much light is filtered before reaching the ground. The interwoven layer of branches and leaves above can be so thick that less than 1% of sunlight penetrates to the forest floor. In some regions, the canopy is nearly impenetrable, with overlapping foliage forming a living ceiling. Scientists have compared this density to concrete because falling rain and even small objects often fail to pass through easily. This natural shield protects the understory, keeping it cooler and more humid than the open air above. It also allows many animals and plants to live their entire lives high in the treetops without ever touching the soil. For them, the canopy is the true forest, complete with pathways of vines and platforms of branches. Forest canopies contain entire miniature worlds. High above the forest floor exists a hidden ecosystem filled with life. Mosses, orchids, and bromeliads grow on branches, forming tiny gardens that collect rainwater in their leaves. These small pools become homes for frogs, insects, and even miniature crustaceans. Ant colonies carve tunnels through wood, while birds and monkeys move between treetops. Scientists who explore these aerial environments often describe them as entering another planet. The canopy effectively doubles the surface area of the forest, creating layered habitats stacked vertically. For centuries, this world remained mostly unexplored. Today, canopy research reveals it to be one of the most diverse ecosystems on Earth. More species may live in forest canopies than on the ground. It may seem logical to assume that most forest life exists near the soil, but in rainforests, the opposite is often true. The canopy hosts extraordinary biodiversity. Birds, insects, reptiles, and mammals find food and shelter among branches. Many plant species grow only in this layer, never touching the ground. Scientists believe that more than half of rainforest species may live primarily or entirely in the canopy. Each square meter of treetops can contain more life than entire meadows elsewhere. Some researchers even describe the canopy as the true rainforest because it supports the majority of its inhabitants. For the creatures living there, the treetops form a bustling city in the sky. Forest floors receive very little sunlight. Beneath towering canopies, forest floors remain in near constant shadow. In dense rainforests, often less than 1% of sunlight reaches the ground. This low-light environment shapes everything that grows there. Plants adapt by spreading wide leaves to capture limited sunlight. Some species bloom directly on tree trunks, where light filters through small gaps. The cool, humid conditions also support decomposers such as fungi, termites, and beetles that recycle fallen material. For many animals, the darkness provides protection from predators, while others rely on enhanced senses of smell or hearing to navigate. Although the forest floor may seem quiet, it remains full of movement and life. Some trees grow for decades without ever seeing direct sunlight. In crowded forests, competition for light is intense. Many trees grow tall and fast, racing toward the canopy. Others remain trapped in shade. Some saplings survive for decades beneath larger trees without ever receiving direct sunlight. Instead, They rely on filtered light passing through the canopy. Remarkably, many shade-tolerant species can wait patiently for long periods. When a large tree eventually falls and sunlight reaches the ground, these waiting saplings rapidly surge upward. This slow patience is woven into forest life cycles. Even fallen trees create opportunity, opening space for new growth to emerge. Some forests are so dark they resemble nighttime at midday. In certain rainforests, canopy density is so extreme that the forest floor appears dim even at noon. Travelers describe these environments as hushed and otherworldly, filled with deep shadows and muted colors. In this low-light world, animals have evolved remarkable adaptations. Some insects glow faintly to attract mates, while larger animals depend more on sound than sight. The darkness keeps temperatures cooler and humidity high, accelerating decomposition. What seems mysterious to humans is simply normal for forest life. For creatures living in these environments, daytime and nighttime often look surprisingly similar. Some forests hide ancient human structures beneath their trees. Forests are not only homes for wildlife, they also conceal traces of human civilizations. In the Amazon, modern LiDAR technology has revealed enormous ancient settlements hidden beneath thick vegetation, complete with road systems, canals, and pyramid-like platforms. In Cambodia, the ruins of Angkor were swallowed by jungle for centuries before being rediscovered. Dense forests can hide stone temples, forgotten villages, and lost trade routes for generations. Roots wrap around staircases, trees grow through walls, and moss slowly covers carvings until ruins appear to merge with nature itself. For archaeologists, forests serve both as protectors and obstacles, preserving structures while keeping them hidden. Each discovery reminds us that the boundary between human history and wild landscapes is far thinner than it seems. Forests are layered not only with plants and animals, but also with echoes of civilizations long gone. Entire ecosystems exist inside hollow trees. A hollow in the trunk of an old tree may appear empty at first glance, but for many species, it becomes a complete habitat. Rainwater collects inside these cavities, forming small ponds where insects, frogs, and even tiny crabs can live. Birds nest within sheltered hollows, while bats and squirrels use them as safe resting places. Microorganisms thrive in damp wood, recycling nutrients that feed surrounding plants. In tropical forests, tree hollows can be so common that they support entire communities of life. Each hollow becomes a miniature ecosystem, balancing water, nutrients, and living creatures in a small enclosed world. These spaces remind us that forests operate on every scale, from vast canopies to tiny pockets hidden within trunks. Bamboo forests can grow taller than skyscrapers in just weeks. Bamboo is technically a type of grass, yet in forests where it dominates, it behaves like a fast-growing giant. Certain bamboo species can grow nearly 1 meter in a single day under ideal conditions. Within weeks, young shoots rise upward, forming dense green towers that resemble skyscrapers made of living stems. In Asia, bamboo forests provide homes for red pandas, golden monkeys, and the famous giant panda, which relies almost entirely on bamboo for food. Humans also depend on bamboo for construction materials, furniture, food, and textiles. Its rapid growth makes it one of the most renewable plant resources on Earth. Walking through a bamboo forest feels unique. Tall stalks sway and creak in the wind, producing soft, rhythmic sounds that give the forest a musical atmosphere. Some rainforest trees produce flowers directly from their trunks. In most forests, flowers grow on branches high above the ground, but many rainforest species use a different strategy known as cauliflory. These trees produce flowers and fruits directly from their trunks. This adaptation allows animals such as bats, monkeys, and rodents to reach and pollinate them without climbing into the canopy. Some of the rainforest's most valuable plants, including cacao trees that produce chocolate, rely on this method. Trunks become covered with clusters of blossoms and heavy fruits hanging like ornaments on living columns. This unusual growth pattern reflects how plants adapt to dense forest environments, finding creative ways to connect with pollinators and seed dispersers. The Amazon rainforest releases more oxygen than all global grasslands combined. The Amazon is often called the lungs of the planet. While this phrase is simplified, it reflects an important reality. The rainforest releases enormous amounts of oxygen into the atmosphere through photosynthesis. Each day, billions of leaves absorb carbon dioxide and release oxygen as a byproduct. Although grasslands also contribute, the sheer size and height of rainforest trees allow them to process far greater volumes of air. Some trees rise hundreds of feet into the sky, increasing the total surface area available for gas exchange, while much of the oxygen produced is later consumed by organisms within the forest itself. The Amazon's contribution to atmospheric circulation remains massive. Forests drive much of Earth's oxygen exchange. Oceans play a major role in oxygen production, but forests are equally essential in maintaining atmospheric balance. Through photosynthesis, forests absorb large amounts of carbon dioxide and release oxygen into the air. At the same time, animals, microbes, and plants consume oxygen and return carbon back into the system. This continuous cycle keeps Earth's atmosphere stable. Unlike deserts or grasslands, forests operate this process across multiple vertical layers of vegetation, greatly amplifying its effect. Forests act as stabilizers, smoothing fluctuations in atmospheric gases and supporting life across the planet. Every breath humans take is supported not only by oceans, but also by forests, quietly converting sunlight into breathable air. Some trees store water inside their trunks, like living reservoirs. In certain forest regions, survival depends on enduring long dry seasons. Some trees have evolved the ability to store water directly within their trunks. These natural reservoirs can hold thousands of liters of moisture, allowing trees to survive months of drought. Baobab trees in African forests are among the most famous examples. Their thick, swollen trunks can supply water not only to the tree itself, but also to animals and even humans who carefully extract it. In tropical forests, other species also store hidden reserves inside spongy wood tissues. This adaptation stabilizes entire ecosystems by ensuring that life can continue even when rainfall becomes scarce. Touching such a tree is like touching a living well, quietly guarding water deep within its fibers. Forests store more fresh water than all the world's lakes combined. When people imagine freshwater reserves, they usually think of lakes and rivers. Yet forests hold even more. Much of this water is stored underground in soil layers and aquifers that forests help replenish. Tree roots pull moisture upward, while forest canopies slow rainfall, so it can soak gently into the ground rather than flowing away as runoff. In wetlands and peatlands, water remains locked inside saturated soils and moss layers for centuries. Altogether, these hidden reservoirs exceed the volume of freshwater contained in all lakes on Earth. This makes forests not only habitats for wildlife, but critical components of the global water system. Every drop of rain that filters through leaves and roots becomes part of a cycle that supplies drinking water, irrigation, and climate stability for billions of people. Forests influence the chemistry of the oceans. Forests and oceans may appear to belong to separate worlds, yet they are deeply connected through rivers and atmospheric processes. Nutrients washed from forest soils flow into streams and rivers, eventually reaching the sea. These nutrients support plankton blooms that form the foundation of marine food chains. Forests also affect how much carbon dioxide dissolves in ocean water by controlling atmospheric carbon levels. Even aerosols released by trees can drift over oceans, influencing cloud cover and rainfall patterns that regulate ocean salinity. In this way, forests help shape marine chemistry and biological productivity. The health of ocean ecosystems is linked to forests growing far inland, revealing a partnership that spans continents. Trees can alter the chemistry of rainwater. Rain that falls through forest canopies changes before it reaches the ground. As droplets pass over leaves and bark, they collect organic acids, sugars, and antimicrobial compounds released by trees. By the time this water touches the soil, its chemical makeup has been transformed. Scientists refer to this process as throughfall. The altered rainwater can nourish soil microbes, fertilize seedlings, and sometimes inhibit harmful pathogens. Different forests produce different chemical signatures in rainfall, creating unique underground environments. In this way, trees do not simply receive rain, they actively modify it, shaping the water that feeds their roots and the life beneath them. Some forest rivers appear dark because of leaf chemicals. In parts of the Amazon and other tropical regions, rivers often look brown or almost black, similar to brewed tea. This coloration is not pollution. It comes from tannins, natural compounds released by decaying leaves and plant matter. As rainwater flows through forest soils rich in organic material, it absorbs these chemicals and carries them into rivers. These blackwater rivers tend to be low in nutrients, but very clear, supporting specialized ecosystems adapted to their chemistry. Fish, insects, and aquatic plants living in these waters differ greatly from species in sediment-rich rivers nearby. The result is a mosaic of aquatic habitats shaped directly by forest biology. Leaves in forests can carry traces of ocean spray. It may seem unlikely that ocean water could reach forests far inland, yet it happens regularly. Tiny salt particles lifted from crashing waves can travel hundreds or even thousands of miles through the atmosphere. Eventually, these particles settle on forest leaves and soil. Scientists had detected traces of ocean salt on vegetation far from any coastline. These particles can influence how leaves absorb water and interact with sunlight. They may also serve as starting points for chemical reactions in the atmosphere above forests. This subtle exchange connects forests and oceans in unexpected ways, allowing distant seas to leave microscopic fingerprints on tree canopies. Leaves in forests can change color even without autumn. In temperate regions, changing leaf colors are usually linked to fall, but in tropical forests, leaves can shift color at any time of the year. Young leaves often emerge in shades of red or orange, acting as a natural sunscreen that protects them from intense sunlight while they mature. Some species change color as a signal, possibly to attract pollinators or to deter insects from feeding. In certain forests, entire sections of canopy can suddenly glow with reds, yellows, or purples without any seasonal change. This constant transformation is one reason tropical forests appear so vibrant and alive. The shifting palette is not driven by cold or frost, but by survival strategies embedded in leaf biology. At any moment, the forest is quietly repainting itself with subtle bursts of color. Forests influence the migration routes of birds across the globe. For countless bird species, forests are not only permanent homes, but also vital resting points along long migratory journeys. Many birds rely on forest habitats as stopover locations, where they can rest and refuel while traveling thousands of miles. The presence or absence of forest cover along migration routes often determines whether these journeys succeed. Some forests produce fruit at precisely the right time of year, providing essential energy for birds crossing oceans or deserts. Others offer shelter from predators and harsh weather. Even species that do not permanently live in forests depend on them during key stages of migration. As a result, forests help shape global movement patterns, guiding flocks across continents and hemispheres. When forests disappear, entire migration routes can collapse. Forest elephants shape the structure of African rainforests. In the Congo Basin, forest elephants play a role far greater than their size alone suggests. As they move through dense vegetation, they create pathways that allow sunlight to reach the forest floor. They feed on fruits and carry seeds across long distances, depositing them in nutrient-rich waste that helps new plants grow. Some tree species can only germinate after their seeds pass through an elephant's digestive system, making these animals essential gardeners of the forest. Over time, elephants influence which trees dominate and how dense the canopy becomes. Without them, certain forest regions would become overcrowded, while others might lose important plant species. Forest elephants are not just inhabitants of the rainforest. They are ecological engineers, actively shaping the landscape around them. Bats and birds help forests regenerate by spreading seeds. Forests do not rebuild themselves alone. They rely on animals to carry seeds across wide areas. Bats feed on fruit at night and scatter seeds while flying long distances. Birds perform the same task by eating berries and later depositing seeds in new locations. These flying dispersers allow forests to expand beyond the shade of parent trees. In some regions, bats are responsible for more than 90% of seed dispersal after disturbances such as fires or logging. Birds also play a major role in maintaining genetic diversity by spreading seeds across landscapes. Without these animals, forests would struggle to recover and would become fragmented. Every wing beat in the night sky and every morning bird call contributes to the continuous renewal of forest ecosystems. Some birds guide humans to hidden honey in forests. In parts of Africa, a remarkable partnership exists between people and a small bird called the greater honey guide. These birds have evolved to lead humans directly to wild beehives hidden deep within forests. The honey guide attracts attention with special calls and then flies ahead, pausing to ensure humans continue following. Eventually, it brings them to honey-filled nests that would otherwise be difficult to locate. After people collect the honey, the birds feed on leftover wax and larvae. This cooperative relationship has existed for thousands of years and represents one of the few known cases of intentional communication between wild animals and humans for mutual benefit. It highlights how forests are not only places of competition, but also of unexpected cooperation between species. The Amazon rainforest contains more species than any other forest on Earth. No other forest matches the Amazon in biological richness. Covering more than 5 million square kilometers, it is home to over 16,000 tree species and countless animals, insects, and fungi. Scientists estimate that 1 in every 10 known species on Earth lives within this vast ecosystem. Each layer of the forest adds another level of diversity. The canopy hosts monkeys and birds. The understory shelters jaguars and reptiles. Rivers teem with fish and dolphins. Despite centuries of exploration, new species continue to be discovered regularly. The Amazon is not simply a forest. It is a living archive of life on Earth, still being explored page by page. Some forests are so remote that they remain largely unexplored. Even with modern satellites and mapping technology, there are forests so dense, vast, and difficult to access that humans have barely entered them. Deep regions of Papua New Guinea, remote areas of the Congo Basin, and isolated valleys of the Amazon remain mostly untouched by scientific exploration. Researchers believe these regions may hide thousands of undiscovered species, from insects and plants to mammals. While local communities may know these lands well, to the outside world they remain blank spaces on the map. Swamps, steep terrain, thick vegetation, and sheer isolation make exploration extremely challenging. These forests remind us that Earth still holds wild places beyond full human understanding. In their depths, life continues on its own terms, unmeasured and unseen, just as it has for millions of years. Some forests grow on floating islands of vegetation. In river floodplains and wetlands, entire forests can form on mats of floating plant material. These mats develop when roots, soil, and organic debris interlock so tightly that they become buoyant. Trees and shrubs grow on top of this surface, creating drifting islands of forest known as suds in Africa and floating meadows in South America. These ecosystems slowly move with currents and winds. Fish feed among dangling roots, while birds nest in thick vegetation above the water. For humans, floating forests can be both obstacles to navigation and sources of grazing land. These strange landscapes blur the line between land and water. Walking across them feels like stepping on soft ground that gently sways beneath your feet, reminding us that forests can exist even without solid earth below. Forests also exist beneath the ocean surface. Forests are not limited to dry land. Beneath the waves, kelp forests rise from the seafloor, anchored by root-like structures called holdfasts. These towering algae can grow over 100 feet tall, forming underwater canopies where sunlight filters down, much like in terrestrial forests. Fish swim between fronds, sea otters hunt among the stems, and seals glide through green corridors. Like land forests, kelp forests provide shelter, shade, and abundant food. They rank among the most productive ecosystems on the planet. Along coastlines in places such as California and Chile, kelp forests support fisheries and reduce wave energy, helping protect shores from erosion. Though they are not made of trees, their structure and function mirror forest ecosystems so closely that they are often called the ocean's forests. Some forests grow on active volcanic slopes in regions such as Indonesia, Japan, and Central America. Forests thrive on the sides of active volcanoes. These landscapes are risky but fertile. Volcanic soil is rich in minerals that promote plant growth. After eruptions, new lava flows quickly become colonized by plants that send roots into cracks and begin rebuilding ecosystems. Over time, forests return, followed by animals that reclaim the land. Living on volcanic slopes means adapting to both destruction and renewal. Forests in these areas demonstrate how life not only recovers from disaster, but often depends on it. Each eruption resets the landscape, allowing new forests to emerge from ash and stone. The Black Forest inspired some of the world's darkest fairy tales. Germany's Black Forest is famous for its towering evergreens, deep shadows, and mist-filled valleys. For centuries, its atmosphere has fueled human imagination. The Brothers Grimm drew inspiration from these dense woods when recording folk tales filled with witches, wolves, and lost children. The forest's darkness and isolation made it a natural setting for stories of danger and mystery. Yet this same forest also supports rich wildlife and peaceful villages. What humans once feared as wild and threatening was simply home to countless species. The Black Forest reminds us that forests shape not only ecosystems, but also culture, myths, and imagination, becoming stages where human stories unfold. Ancient forests have been preserved in stone for hundreds of millions of years. Long before humans existed, forests covered much of the planet. In some places, these ancient forests were preserved as fossils. Petrified forests found in regions such as Arizona, Argentina, and Antarctica contain trees that have turned to stone over vast spans of time. Minerals slowly replaced organic material, preserving fine details like growth rings and bark textures. These fossil forests reveal what ecosystems looked like in prehistoric eras, including species that no longer exist. Walking among them feels like stepping into deep time, where ancient trunks remain frozen in place. They stand as reminders that forests are not only part of the present, but also part of Earth's long and ancient history. Forests are expanding again in some parts of the world. Although deforestation remains a serious global issue, not all forests are shrinking. In several regions of Europe, North America, and Asia, forest coverage is slowly increasing. This regrowth often happens when farmland is abandoned or when large-scale reforestation programs take root. Across Europe, centuries-old agricultural fields are gradually being reclaimed by trees. In China, massive planting initiatives have added billions of new saplings to the landscape. While these young forests do not yet match the complexity of ancient ecosystems, they begin attracting wildlife, restoring soil health, and capturing carbon over time. This recovery offers hope that damaged environments can heal when given space and care. Forests, though fragile, also possess remarkable resilience. Some forests are growing where deserts once spread. In parts of Africa, Asia, and the Middle East, trees are beginning to take root in regions that were once barren. This transformation is often the result of human-led restoration efforts aimed at reversing desertification. Projects such as China's Great Green Wall involve planting millions of trees to slow the advance of expanding deserts. In the Sahel region of Africa, communities plant native species that tolerate dry conditions, helping rebuild soil fertility and restore shade and moisture. Climate shifts also contribute by altering rainfall patterns and creating opportunities for vegetation to return. These emerging forests may not yet rival ancient rainforests, but they prove that even harsh landscapes can recover. With time and effort, land that once appeared lifeless can bloom again. Some of the world's rarest forests exist only on small islands. Across the oceans lie islands that support forests found nowhere else on Earth. The cloud forests of Hawaii, the dragon blood tree groves of Socotra, and the palm forests of the Seychelles exist in fragile isolation. These habitats often contain species that evolved separately from the rest of the world. Because of their limited size, even small disturbances can have dramatic effects. Storms, invasive species, or human activity can permanently alter these ecosystems. Yet their rarity makes them biological treasures, living museums of evolution. Walking through these forests feels like stepping into another world where life has followed a unique path shaped by isolation. Some of the smallest forests on Earth are only a few trees wide. Not all forests stretch across continents. In some regions, clusters of trees only a few dozen meters across are still classified as forests. These miniature woodlands may grow along rivers, in valleys, or on isolated hills. Despite their small size, they often support surprising biodiversity. Birds, insects, and small mammals use these patches as refuges in otherwise open landscapes. Scientists have discovered that even tiny forests can store carbon, regulate water flow, and protect soil from erosion. For nearby communities, they may provide shade, food, or cultural significance. These small forests show that size does not determine importance. Even a handful of trees growing together can carry the full function and spirit of a forest. Some forests contain species found nowhere else on the planet. Isolation creates uniqueness. Forests separated by mountains, oceans, or rivers often develop species that exist in no other place. Madagascar's forests shelter lemurs and baobabs, unlike anything found elsewhere. Australia's eucalyptus forests support marsupials and birds, shaped by millions of years of isolation. Even small forest patches can protect rare plants and insects that never spread beyond their original range. These species are often highly vulnerable, dependent on specific habitats for survival. Their existence reflects the creative power of evolution, shaping life to fit local environments. Every forest becomes a stage for biological experiments millions of years in the making. Forests can signal changes in upcoming weather. Forests are not passive observers of the atmosphere. They respond to subtle environmental shifts and provide clues about approaching weather. Scientists have discovered that changes in leaf chemistry, humidity, and insect activity can indicate shifts in temperature or rainfall before they occur. Indigenous communities have long relied on these natural signals, reading bird calls, flowering patterns, and tree behavior to predict storms. In this way, forests act as natural forecasting systems. As trees release moisture and chemicals into the air, they also influence cloud formation, creating feedback loops that shape local weather. Walking through a forest can feel like stepping into a living weather instrument, where every scent, sound, and movement carries hints of what is to come. Forests at night can be louder than cities. When the sun goes down, many forests do not become silent. Instead, they awaken in a different way. Frogs begin calling, insects create steady hums, owls echo through the darkness, and mammals move quietly through the undergrowth. In tropical forests especially, the combined sound of nocturnal life can rival or even exceed the noise level of busy urban streets. Researchers who record nighttime soundscapes often find multiple layers of calls overlapping, from deep, low tones to sharp, high-pitched chirps. Each sound occupies its own space in the acoustic landscape, forming a living orchestra. This nighttime chorus is not random noise. It is communication, territory marking, and survival expressed through sound. For humans, the effect can feel overwhelming at first, yet deeply immersive. It reminds us that forests never truly sleep. They simply change their voice. Forest soundscapes shift dramatically from dawn to night, from early morning light to the stillness of midnight. Forests move through cycles of sound as complex as any musical composition. At sunrise, birds greet the day with waves of song. As the air warms, insects gradually take over, filling the forest with steady buzzing rhythms. Afternoon rain often adds its own percussion as drops strike leaves and branches. When evening arrives, frogs begin calling, followed by nocturnal insects and mammals. Each group occupies a specific time window, carefully spaced so their signals can be heard without interference. Scientists studying these patterns have discovered that forest soundscapes are highly organized. Every species adjusts its timing to fit into the broader acoustic rhythm. Listening through an entire day reveals the forest's heartbeat, measured not in silence, but in shifting layers of sound. Insects provide the constant background music of forests. In many ecosystems, insects are the most persistent musicians. Cicadas, crickets, and countless other species create continuous choruses that rise and fall like breathing. Some cicada species emerge in synchronized waves, filling entire regions with powerful sound that can travel for miles. Others sing nightly, weaving overlapping rhythms that researchers compare to structured musical patterns. These insect sounds serve critical purposes. They attract mates, define territory, and confuse predators. For humans, they often become the defining sound of warm forest nights. While birds and mammals may come and go, insects maintain the steady pulse that keeps the acoustic life of the forest alive. Without them, the forest would feel strangely empty, missing its constant vibration of sound. Some forests preserve clues to Earth's earliest evolution. Certain ancient forest regions contain living traces of early life on Earth. Fossil-rich areas such as Canada's Mistaken Point preserve imprints of primitive organisms that lived long before complex forests formed. Even modern forests contain plant lineages that stretch back hundreds of millions of years. Cycads, often described as living fossils, still grow in tropical forests, much as they did during the age of dinosaurs. These species link present-day ecosystems to prehistoric landscapes. Within their leaves, spores, and seeds lie genetic records of adaptation and survival. Forests are not only alive in the present moment, they serve as biological archives, storing evidence of Earth's deep evolutionary history. Roots beneath forests can extend for vast distances. Below the visible surface of a forest lies a hidden network as extensive as the canopy above. Tree roots spread outward and intertwine, forming underground systems that can stretch for miles. In mangrove forests, roots reach into rivers and coastal waters, stabilizing shorelines while drawing nutrients from deep soil layers. In temperate forests, roots often connect neighboring trees, allowing them to share water and minerals. These networks are strengthened by fungal connections known as the wood wide web. Through this system, trees exchange sugars, chemical signals, and warnings of danger. A forest is not simply a group of separate individuals. It is a connected community bound together beneath the soil. Some forest trees produce natural insect repellents. Many trees defend themselves by producing chemical compounds that discourage insects from feeding on their leaves. Eucalyptus trees release aromatic oils that repel pests and suppress competing plants. Pine trees produce sticky resin that traps insects and sends out strong warning scents. Some species adjust these defenses depending on the season or intensity of attack. Humans have learned to use these natural chemicals as well. Many essential oils and plant-based repellents come directly from forest species. This invisible chemical defense system helps forests survive despite constant pressure from herbivores. Each breeze carrying the scent of pine or eucalyptus is not just pleasant fragrance, but part of a living protective shield. Trees can warn each other about predators. Trees are not passive when animals begin feeding on them. Research in African savannas has shown that when giraffes feed on acacia trees, the damaged trees release chemical signals into the air. Nearby acacias detect these signals and respond by increasing bitter compounds in their leaves, making them less appealing to herbivores. This coordinated response allows entire groves to protect themselves. It shows that trees actively participate in their environment, reacting quickly to threats. This shared defense strategy strengthens forest resilience and prevents overgrazing. The forest behaves like a collective organism, responding together to maintain balance. Trees in forests can support injured neighbors. In some ecosystems, trees appear to assist one another during times of stress. When a tree becomes damaged or weakened, nearby trees can send sugars and nutrients through underground root systems and fungal networks to help sustain it. Researchers have even discovered ancient tree stumps with no leaves that remain alive for centuries, nourished entirely by surrounding trees. This sharing behavior helps maintain forest stability by preserving root structures, preventing erosion, and reducing gaps in the canopy. It suggests that forests prioritize collective survival over individual strength. What may seem like kindness is actually a complex biological cooperation system. A forest is not simply a collection of separate trees. It is a living community where resources flow where they are needed most. Forests are often called the lungs of the planet, but their role is much larger. Trees absorb carbon dioxide and release oxygen, earning forests the nickname Earth's lungs. Yet this description captures only a fraction of their true function. Forests regulate rainfall, stabilize soil, cool the atmosphere, and support enormous biodiversity. They shape weather patterns across continents and influence the global carbon cycle. Forest ecosystems provide food, medicine, shelter, and clean air for countless species, including humans. In reality, forests act more like the planet's life support system, combining the roles of lungs, heart, and circulatory network. They keep Earth balanced in ways that go far beyond breathing alone. Tree rings record centuries of climate history. Each year, trees add a new growth ring to their trunks. During dry years, these rings are narrow. During wet years, they grow wider. Over long periods, these patterns create detailed records of past climate conditions. By studying tree rings, scientists can reconstruct rainfall patterns, temperature changes, and even the effects of volcanic eruptions that happened long before written history. Some ancient trees preserve over 1,000 years of climate data inside their wood. This field of study, known as dendrochronology, allows researchers to understand how forests and ecosystems responded to environmental changes in the past. Every tree trunk becomes a living archive of time. Forests influence Earth's climate more than we often realize. The impact of forests goes far beyond carbon storage. Trees release water vapor into the air, helping form clouds that reflect sunlight and cool the planet. Dark forest canopies absorb heat, while lighter forests reflect it, affecting temperature balance. Chemical compounds released by trees influence cloud formation and rainfall patterns thousands of miles away. For example, the Amazon rainforest helps stabilize weather systems across entire continents. When forests are removed, these climate-regulating processes are disrupted. Forests are not passive participants in Earth's climate system. They actively shape it. Forests may cool the planet more than scientists once believed. Recent research suggests that forests play a stronger cooling role than previously estimated. Through evaporation and transpiration, trees release moisture that lowers surrounding temperatures. This natural cooling effect can reduce regional heat by several degrees. Forests also increase cloud cover, reflecting sunlight and preventing excessive warming. Together, these processes may offset more global warming than earlier models predicted. In a changing climate, forests are not only victims of environmental stress. They are powerful allies in stabilizing temperature and protecting ecosystems. Every forest holds both ancient history and new life. Forests exist in multiple layers of time. Some trees have stood for centuries or even thousands of years, while new seedlings emerge every season. Beneath the soil lie traces of forests that existed millions of years ago. At the same time, young shoots prepare the canopy of the future. Each forest is both an archive and a frontier. When people walk among trees, they move through overlapping generations of life. Forests are never frozen in the past. They are constantly renewing themselves, carrying ancient memory while creating new growth. Forests still hide mysteries we have not yet uncovered. Despite centuries of exploration and scientific research, forests continue to hold countless secrets. New species of plants, insects, and fungi are discovered every year, many hiding in plain sight. Scientists are still learning how trees communicate, how fungal networks shape ecosystems, and how deeply forests influence the global climate. Even the true number of species living in the Amazon and Congo basins remains unknown. In many ways, forests remain as mysterious as deep oceans or outer space. Each step beneath the canopy leads into territory that science has only begun to understand. Some forests contain trees that release red-colored sap. In regions of Africa, Asia, and South America, certain tree species produce sap so vividly red that it resembles blood. The most famous example is the dragon blood tree found on the island of Socotra. Its crimson resin has been used for medicine, dye, and ceremonial purposes for thousands of years. When the bark is cut, thick red liquid flows outward, giving the tree an almost mythical appearance. Other species, including some eucalyptus varieties, also release reddish sap. What appears dramatic or mysterious is actually part of the tree's natural defense system. These resins help seal wounds and protect against bacteria and insects. Some rainforest trees grow taller than famous monuments. Deep within tropical rainforests, towering trees have been measured at heights exceeding 80 meters, making them taller than the Statue of Liberty. Species such as Denitzia excelsa rise far above the canopy, standing as natural skyscrapers within the forest. These giants capture sunlight before other trees can reach it, giving them a powerful ecological advantage. Their branches host entire communities of birds, insects, and epiphytic plants. Because of their size, they also store massive amounts of carbon, strengthening the forest's role in climate regulation. Standing beneath one of these giants, creates a sense of awe, similar to looking up at a man-made tower. Yet this structure is alive and deeply rooted in the earth. The largest tree by volume outweighs many animals combined. In California's Sierra Nevada stands the General Sherman tree, a giant sequoia known as the largest living tree by volume on Earth. Its massive trunk contains more than 1,000 cubic meters of wood. By weight, it exceeds dozens of blue whales combined. Although it is not the tallest or the oldest tree, its sheer size makes it one of the most impressive living organisms on the planet. Thousands of years of steady growth have created a monument of living tissue. Mosses, birds, and insects live on its surface, turning the tree into an ecosystem of its own. Bamboo forests grow with astonishing speed. Bamboo is technically a grass, yet in forests where it dominates, it grows faster than nearly any other plant. Some species can increase in height by almost a meter in a single day. This rapid growth allows bamboo forests to recover quickly after harvesting or natural disturbances. Bamboo's hollow and flexible structure gives it strength while remaining lightweight. Humans have used bamboo for construction, food, textiles, and tools for thousands of years. In natural ecosystems, bamboo provides shelter and food for many animals, including the giant panda. Its fast growth also helps stabilize soil and prevent erosion. Forests reshape landscapes over long periods of time. Over centuries and millennia, forests slowly transform the land they grow on. Tree roots break apart rocks, turning solid stone into fertile soil. Fallen leaves accumulate and decompose, building thick layers of organic material that support new growth. Forests capture rainfall and guide the flow of rivers, sometimes altering water pathways entirely. In regions like the Amazon basin, forests recycle water within the ecosystem, maintaining the conditions that support the landscape itself. These changes happen gradually, often unnoticed by human eyes, yet they represent one of nature's most powerful forces. The Amazon River was once surrounded by vast swamp forests, long before the Amazon became the massive river system we know today. Much of its basin existed as an enormous wetland filled with trees and slow-moving water. Around 10 million years ago, tectonic shifts and the gradual rise of mountain ranges blocked natural drainage routes, creating sprawling swamp forests. Fossil evidence suggests these ancient wetlands supported enormous crocodiles, giant turtles, and dense vegetation adapted to constant flooding. Over millions of years, geological changes allowed water to break through and carve the modern course of the Amazon River. Even today, the forest retains traces of this watery past in its floodplains and seasonal wetlands. The Amazon is not simply a river flowing through a forest. It is the result of forests and water shaping one another across deep time. Some forests are shaped by seasonal flooding. In regions such as the Amazon basin and parts of Southeast Asia, forests regularly experience long periods of flooding. Water levels can rise several meters and remain high for months at a time. Instead of dying, many tree species adapt. Some develop hollow stems that allow oxygen to reach underwater roots. Others form specialized root structures that tolerate long submersion. During flood seasons, these forests become temporary aquatic ecosystems, providing shelter and breeding grounds for fish and other water-dwelling animals. When waters recede, nutrient-rich sediment is left behind, fueling rapid plant growth. Life in these environments follows a rhythm of flood and drought, creating forests that function both on land and in water. Forests once covered nearly all of Earth's land surface. Hundreds of millions of years ago, before deserts expanded and polar ice caps formed, forests blanketed much of the planet. During the Carboniferous period, massive swamp forests dominated the landscape, creating the coal deposits used today. Later, ancient conifer forests stretched across supercontinents, forming continuous green belts that spanned thousands of kilometers. These early forests played a major role in shaping Earth's atmosphere, increasing oxygen levels and enabling the rise of giant insects and amphibians. Over time, climate changes and shifting continents broke these vast forests into the ecosystems we recognize now. Yet the memory remains. At one point in Earth's history, the planet was almost entirely green. Forests will outlast most human structures. Buildings, roads, and monuments may appear permanent, yet forests quietly demonstrate the true scale of time. Abandoned cities are slowly reclaimed by vegetation as roots crack concrete and vines weave through empty windows. Even ancient fortresses and temples eventually collapse beneath the steady pressure of growing trees. Forests move slowly, but their persistence is unmatched. They have survived the rise and fall of civilizations and will likely continue long after many modern structures have faded. Human construction measures permanence in centuries. Forests measure it in millennia. Forests show both fragility and strength. Forests can be destroyed quickly by fire, logging, or drought. Their vulnerability is visible in clear-cut hillsides and burned landscapes. Yet forests also survive ice ages, violent storms, and massive environmental change. Given time, they regenerate, returning life to damaged land. A small seedling may seem fragile, but with patience, it can grow into a towering giant. Entire forests can disappear and then slowly reappear, green and vibrant once again. This balance between vulnerability and resilience makes forests powerful symbols of life itself. The journey through Earth's forests comes to a quiet close. As we reach the end of this long exploration, imagine once more the calm of walking beneath tall canopies. From towering redwoods to hidden fungal networks beneath the soil, forests reveal how vast and interconnected life truly is. They are ancient yet constantly renewing, delicate yet powerful, mysterious yet familiar. Even when we are far from wilderness, forests remain close. Every breath of air, every drop of water, and every heartbeat carries a trace of their influence. Forests hold the memory of the planet and also its hope for the future. If this gentle journey brought you calm, consider sharing your thoughts or supporting the channel. Each small gesture helps others discover this peaceful space. For now, allow your breathing to slow. Let your body relax. Let the quiet presence of forests remain in your mind like a soft green shelter. Rest comes easily when we let go. The night is calm. Tomorrow can wait. Sleep gently